Okay, so today we're going to start our conversation about slopes. We are starting Unit 3, so this is our first introduction into linear equations. So let's go ahead and get started with slopes. So the first thing I want to look at is, what does slope look like? So there are four things that we're going to look at, four different graphs. So the first one looks like this. And so I like to think about this guy walking along the slope to decide what kind of slope that is. So if he's walking from left to right, he's walking uphill. And so we call that a positive slope. The next one looks like this. So again, we put our guy on there. This time, from left to right, he's going downhill. So we call this a negative slope. The next situation looks like this. And we put the guy on there. And if he walks, he's not walking uphill or downhill. He's just walking at a steady incline, or no incline, zero incline, and so we call that a zero slope. The last case looks like this. So if I put this guy on this one, he would have to walk straight down. Well, we know that we can't walk straight down like that because we would plummet to our death. So we would fall all the way down, and so we call that an undefined slope, or no slope. So it's important to keep these two separate, or keep them straight. The horizontal line would be walking along. You could walk along that, and that's a zero slope. The vertical line, you can't walk along that. You would plummet to your death, and so we call that no slope. So what are we going to do with slopes? Well, let's take a look at a couple different ways that we can find slope. So the first way is looking at these tables. You should be familiar with these because we looked at them when we were talking about functions in the last unit. This is just a table of values. We know that the x is our domain and the y is our range. So what we're going to look at today is, how much does it change between each number on the x's and each number on the y's. So let's start with the x's. So if I start with 2, what do I have to do to get to 4? Well, I have to add 2. Well then, let's look at 4 to 6. So again, to get from 4 to 6, I have to add 2. And then we look at 6 to 8. And again, we have to add 2 to 6 to get to 8. Let's do the same thing for the y values, or our range values. So we start at -1. What do I have to add to -1 to get to 0? Well, I have to add 1. And then to go from 0 to 1, I have to add 1. And to go from 1 to 2, I have to add 1. So when we talk about slope, it is the change in y, or the change in the range values, over the change in x, the change in the domain values. So the change in y in this case is 1 each time, and the change in x is 2. So my slope is 1 over 2. We always use that m as our variable to represent slope. That's just a standard that we use. So this is the change in y over change in x, or 1 over 2. So this has a slope of 1/2. Let's take a look at another table. So let's go from point to point. Let's look at our x values first. So to go from -4 to 1, I have to add 5. To go from 1 to 6, I have to add 5. To go from 6 to 11, I have to add 5. So the change in my x values is 5 each time. Let's look at the y's. To go from -2 to 2, I have to add 4. Then to go from 2 to 6, I have to add 4. And to go from 6 to 10, I add 4. So if I look at my slope, again, which is change in y over change in x, the change in y is 4, the change in x is 5, so the slope is 4 over 5. Let's look at one more of these. So here's our table. So let's look at going from 1 to 3. This is our change in x's. To get from 1 to 3, I have to add 2. Then to go from 3 to 4, I have to add 1. And to go from 4 to 6, I have to add 2. Well, in all the other examples, those numbers were the same. This time they're not, so it looks like something weird is going on. Let's keep going and see what happens with the y's. So to look at -1 to 3, I have to add 4. And to go from 3 to 5, I add 2. And to go from 5 to 9, I add 4. Again, they're different. So let's take a look at each individual change. So between the first two numbers, the change in y was 4 and the change in x was 2. So it would be 4 over 2. The next one would be the change in y was 2 and the change in x was 1, or 2 over 1. And the last set was 4 over 2. Well, if we remember, 4 over 2 is just 2 over 1. So it is the same ratio as that middle one of 2 over 1. So I always want the reduced form of the ratio, and if they all reduce to the same one, then it's a function, it's a linear function, and it has a slope of the reduced form, which is 2 over 1. So the change in y was 2 and the change in x was 1. Let's look at what we do if we have 2 points and we want to find slope. So the first one is 3, 2, the first point. So let's graph that. And then let's graph the second point, 6, 7. So there they are graphed. Now remember, slope is the change in y over change in x. So let's just see how much they changed. So to start at that first point, I have to go up to get to that next point. That's my y move, and I have to go up 5. Then I have to go over, that's my x move, and I had to go over 3. So my change in y is 5, and my change in x is 3, so my slope is 5 over 3. Let's look at another one. So now I have 5, negative 3, and I have 4, 2. So let's graph those. There's 5, negative 3, and there's 4, 2. So let's see what I have to do to get from one point to the next. So I want to do my check my change in y first, so I have to go down. This time I go down 5, and then I just go over 1. So my change in y is negative 5, my change in x is positive 1. So I can also look at the points to tell me what that is. So if I think about my y values on the points, my y values are negative 3 and 2, and my x values are 5 and 4. So to find the change in my y's, I'm going to subtract them. To find the change in my x's, I'm going to subtract them. So it looks like this. I have negative 3 minus 2, which is negative 5. And then I have 5 minus 4, which is 1. And that's exactly what I got in the picture. I got a change of negative 5 over a change in 1, which just reduces to a slope of negative 5. The thing to remember is you have to use, if I use 5 first for my y, I have to use negative 3 first. I have to keep the same point first every time. Let's look at another one of these. Here's 2 points. Let's graph negative 2, 1 first, and then let's graph 3, 5. So there are the 2 points. So let's do our change. So I'm going to go up to get to the next point, and I had to go up 4, and then to go over to that point, I had to go over 5. So my change in y is 4, my change in x is 5, so my slope should be 4 over 5. Let's look at using the points, the numbers in the points, to do the same thing. The y values are 5 and 1, so I have 5 minus 1, which is 4, and the x values are 3 minus negative 2. Well, remember, minus negative 2 is the same as adding positive 2, so 3 plus 2 is 5. So my slope is 4 over 5. Not too bad. Now, let's take a look at what happens when we just know the points and we don't want to take the time to graph them, or, maybe we don't need to. If we remember it's the change in y's over the change in x's, then I just subtract the y values and put those on top, and I subtract the x values and put those on bottom. My y values are 4 and 3. My x values are 6 and 1. So I have 4 minus 3 over 6 minus 1. Well, 4 minus 3 is 1, and 6 minus 1 is 5. So my slope is 1/5. Let's do one more of those. So here's the slope. I want to find the slope between 8, 3, and 9, 6. So again, I identify my x values, my y values. Those are 3 and 6, and my x values are 8 and 9. So it's the change in y over the change in x, or 3 minus 6 over 8 minus 9. Well, 3 minus 6 is negative 3, 8 minus 9 is negative 1. So I end up with -3 over -1, which just reduces to +3, because when I divide a negative by a negative, I get a positive. So I can leave it as 3 over 1, +3 over 1, or I can call it just 3. It doesn't matter, they both mean the same thing. But the slope for these 2 points is 3. So you are going to practice doing some of these. So the first set of problems are just telling whether the slope is positive, negative, 0, or no slope. The next 3 problems are looking at a table and finding the change between the y's and the change between the x's. And then the last set of problems are just using the 2 points, the coordinates of 2 points, and finding the slope. So good luck, and I will see you tomorrow. Thank you.